Hello, everyone. Welcome to the Kubernetes Cluster API Azure Office Hours for February 22nd, 2024. We do this every week on Thursdays. Cluster CapZ is a sub-project of SIG Cluster Lifecycle, the umbrella project, and we abide by the general Kubernetes community rules of conduct, which more or less boils down to please be respectful of everyone else, try not to talk over each other. We try to use the raise hand function on Zoom. At the beginning, we give some time for anyone who is new here or hasn't been here in a long time or just wants to say why they're here to say hello. So I will be quiet for a minute if anyone wants to do that. All right. And yeah, if you want to add your name up here where Willie is typing his in, that's helpful. And let's get going with the open discussion. The first exciting topic is from you guys, Cyan and Tilo. So take it away. Do you need to share screen, I assume?
Yeah, that would be great.
Are you gonna do that? Or,
I'll be doing it, and Cyan will be doing it later.
okay, I think I can make you both. Wait, if I can find that again. Participants, make co-host, and make. Oops, what did I just do? Rename. Make co-host. There we go. Okay, hopefully that's. Oh, actually, it only took for you. Hold on.
If you allow multiple participants to share their screen, it should work for everybody.
Okay, well, I just made you both co-host, which I think accomplishes the same thing, but we'll see if there's any problems.
Can you make Linux me, who joined without video and audio, also co-host
Oh,
for sharing command line? Sorry for being complicated.
no, not at all. I get it.
Awesome.
Okay, see if that works.
Thank you.
Sure.
All right. So we've assembled like a small presentation to lead you into the whole topic and to better display what we're trying to do in Cluster API. A similar thing has been presented to the Cluster API OpenStack provider in December, and we're basically planning to support more providers as time allows, and will pop up in other providers meetings probably. All right, so this is about node provisioning and separating Kubernetes from the node operating system. And what led us here is the challenges that we've encountered with Image Builder and the need for Image Builder to basically run for each update of the operating system and of Kubernetes. The technology we want to present today and for which we have a proof of concept implementation and a PR up is systemd SysExt. And so my part will be to give you a brief intro of what systemd SysExt is and what we're trying to achieve with it. And Cyan will cover the Kubernetes and Cluster API side of things. All right. Systemd SysExt is a way to extend operating systems based on images that only contain the bits that you want the operating systems to extend with. Those merge transparently into /usr or /opt or both. Systemd, starting with version 248, supports that. So most modern Linux distros actually ship it. And it also brings along a independent update concept via systemd sysupdate, which aims to update single files or file system images, like in our case. And let me actually give you like a brief hands-on on how this looks on a node. And now Linux me will share the screen. Okay, This is a like simple node that I've deployed on Azure, and it's a relatively small system. And I don't need like a big system for that because SysX is very lean and it doesn't need resources. So if I look into the current directory, which is an opt, I see two files. The first one is the SysX itself. The second one is the sysupdate configuration, which we're going to take a look in a second. So what I can do is I can actually just mount this thing and then show you that it basically ships a source tree under under /usr that contains the basic bits that I need to run Kubernetes on this node. The main management tool for systemd SysX is called systemd SysX. So when I start this, I can list the system extensions that are known to the system. And since it's a very recent Flatcar version, we see that we ship containerd and Docker and the OEM bits we need to run on Azure as SysX already. So the Kubernetes SysX will seamlessly integrate with that. And this is the directory where systemd SysX basically registers all of the known extensions that are known to the system. Those are soft links to the actual files, and I will now create a soft link to our Kubernetes SysX, which will make it known to systemd. Okay, so when I list the extensions now, then systemd will have found it. But if I check the status of SysX, then we'll see that only 3 extensions are merged. Now what I do is, first of all, usr bin, there is no kubelet here, right? And I can't run kubelet because it's not there. Now if I refresh, if I merge the SysX, which is usually done at boot time, then kubelet will magically appear in the file system, and I will be able to run it. The same is true in reverse. So if I remove the symlink and refresh, then kubelet will be gone again. The specific SysX that we're looking at here comes from a, oh wait, I forgot actually to show you the update config. That one's important. So if you look into the conf file that you've seen here, this goes to systemd sysupdate. It's a very basic file that just points to a HTTPS endpoint and gives yourself a match pattern. So sysupdate is Semver aware, and it gives a few options on where to download and where to create a soft link. And the way this works is systemd sysupdate will, as soon as a new version is available, download that new version, stage it in the path where it's supposed to download the SysX, and then recreate the soft link to the latest version that we've seen now. And then you can refresh, and you will basically have in place upgraded Kubernetes. And that's a very nice way to do that independently of the operating system. Now, the source of this specific SysX, and that's kind of the beauty of this concept, is a GitHub repo. That's something that we call the SysX bakery, and it just has a number of scripts that create the respective sysags with the latest versions that were released upstream. And all those scripts run in a GitHub action. Now, we publish these as a release, and this basically gives you the HTTPS URL. And what systemd sysupdate now does is it just checks this file. I don't know if I can, no, I can't look into it. It's basically, this file contains just SHA sums and file names, and that way it's kind of like a directory index for sysupdate. And that's where sysupdate determines that the new update was published. And that was it from my low-level demo. Let's go ahead a little bit and then look into how this integrates with Cluster API and Kubernetes. So currently, Kubernetes Cluster API images are built by taking a stock distribution image, taking a Kubernetes release, piping that through image builder, adding some custom configurations that is important for the respective cloud that we're building for, which we call a vendor. And as a result, we have a image that has fused in the operating system version, the Kubernetes version, specific configurations, and the cloud vendor. And then the provisioning, the deployment process is basically you need to host your own images. And then you create your worker node instances from those. And then, yeah, that's basically how you set up your worker pools. There are a few drawbacks to that approach compared to systemd sysags. The first is the Cluster API users need to provide their own images because it's a nightmare to maintain and to keep secure images upstream, right? Because you need to take care of the operating system, of Kubernetes, of the respective bits for all of the vendors, all of the clouds. But in our case, it's just Azure because this is the Azure provider. But the problem is shared across providers. Jack, you have a question?
Well, actually, finish this slide and then ask me for my question.
Okay. All right. So what we do is before we provision, we bind Kubernetes Cluster API and all of those versions into one image. If you want to support multiple versions and major releases of operating systems, that creates an exponential version matrix, right? You have Ubuntu 20 with several Kubernetes versions, Ubuntu 22 with several Kubernetes versions, Fedora if you want to support it, and so on and so on. And another dimension in that version matrix is the cloud vendors. Now, and also updates. You better replace your nodes if you update anything, because it's kind of a nightmare to update the Kubernetes bits separately from the operating system, right? So it's better to do blue-green updates and then call it a day. And before the next demo, Jack's question.
Actually, could you go back to that slide if you don't mind? I just wanted to. This all makes sense to me. I wanted to get Matt's sanity check on all these assertions. I think they seem uncontroversial. Do you agree with that, Matt?
I think, yeah, totally. I mean, it's not a big exponential version matrix simply because we've restricted ourselves only to Ubuntu and 20 and 22. Otherwise, because
that's partly because of the exponential matrix outcome. Like we know about that, so we don't.
Yeah. So we don't.
We'd not be eager to adopt more OS. Yeah.
But we publish these images and, then kind of are hands off because, as Tila was just saying, it would be too time consuming for us to patch them with CVEs or update them for any reason. So you're definitely preaching to the choir.
Cool. Thank you.
Awesome. Very good question, by the way. Good feedback. This is not really a provisioning demo. We are just looking at an existing cluster which has been deployed with sysags, so no pre-built images. Sayan.
Thank you, Thilo. As Thilo mentioned, I'll just be going through how we currently provision things and showing how things will change for Flagstaff C6, which is not a big difference. But yeah, this is if folks are looking at the recording and are interested, just to give a small demo. So I'll share my screen. Yeah, so one setup is going through the terminal side. We set up all the environment variables which are required, and then we go ahead and set up our management and workload cluster using like, for example, I was doing with client, so client create cluster, then we create the secret, then the standard process of cluster CTL init, which creates the management cluster, and then we create the config. Here I am, so given the PR is open, I was testing it with the YAML file, the cluster Flatcar C6 template file that I created, and I was and that gave me like a YAML, and then finally applied. So this is standard process, this which you folks already know, and then finally going ahead and installing the CNI. Now, given this is a bit tedious and I'm really helpful for Tilt, so my setup mostly work environment was around Tilt. So let me share my Tilt screen. So yeah, so here I have already done the Tilt setup. So you just do a make tilt up, and then that would give you a it would do all the things on their side and give you a beautiful looking dashboard. And going back to the dashboard again. So yeah, so this is the dashboard. So you have all the resources, you see all the flavors that are supported, and then Tilt automatically detects the new flavor that I had in my system, and then you could just click on the trigger on this button to trigger the setup, and it goes through the whole setup. Right now, like I just clicked on the setup as Thilo was discussing about giving the demo. So I guess the worker nodes might be still be coming up because this whole thing takes a bit of time. So given respecting the time, I just did it beforehand so that we can get to the actual part, which is the SysX. So this is the way to provision. I mean, not very different from the current setup, but yeah. So handing over to Thilo.
Thank you. All right. I need to find my presentation.
Jack, you got a question?
Yeah, just really quick. I assume that Cyan, that new cluster flavor you built was using at least a base image that was prepped with this whatever it's called, SysXT.
Yeah, right.
So that we can now you can like patch it in real time. But there is you did build one new image, I assume.
Yeah, so
to get this going,
right. So
no,
just
Thilo's...
to give an example, just to give you an idea. So our release process, when we do a release process, we do all the release for all the channels, and then we update all the cloud providers. And then now with the cluster API setup, we have a SIG image that gets like the vanilla Flatcast image gets uploaded into the shared image gallery. And then currently what the setup is, we have the latest Flatcar image. So currently what we have is like for every Kubernetes latest version patch release, we build a new image and upload it to our or to the SIG galleries, and then the current Flatcar flavor uses that particular flavor. So it uses the Flatcar version and the Kubernetes version to find the actual image and then use it. So yeah.
It's important to understand that what Cyan is describing is the old way, like the images we publish to the image gallery. That is image builder. What we have in the demo here is using the stock Flatcar cloud image. There are no Kubernetes bits on it, and the only thing we do via the cluster API interface is basically instruct Flatcar to download the image from the bakery and put it in opt and then create a soft link. So it is the stock Flatcar image, and it's supposed to be any stock image down the road of any Linux distro you would want to use. There's a small asterisk attached. I'll get to that later in the presentation.
Right.
Understood.
Yeah. So right now it's just a stock image. I'll probably demo it when I'm showing the next demo for myself. Yeah.
Right. Now, what we currently have in place is this process, which you just asked about, right? So for the SysEx part, and this is kind of the interesting part for this group, right? Because the operating system should be abstracted away. You would take a Kubernetes release and you would put it into a local file system, basically the way Kubernetes expects its binaries to be found. Like we've seen at the very beginning of the presentation, kubelet and /usr/bin and the other stuff, well, where it basically belongs. If you have any specific configuration that you want to add for cluster API and that you want to make it part of this image, you can add then and then bake the image by just calling make squashfs or mkosi or whatever you like to use for building file system images, and you have a cluster API SysEx. And that's exactly what we're doing in the bakery. Now, this is the provisioning part, right? So we take a stock operating system image from whatever provider you're using from the registry. We took the Flatcar image from the Azure Marketplace, and then during provisioning, like generic user config is applied. That's kind of slightly out of context here even. And in this user config, you specify where to pull the SysEx from, right? In our case, it just pulled it from the bakery. It could be pulled from an official HTTPS endpoint of this group. And you would basically keep up to date all of the Kubernetes versions for the cluster API nodes that you'd be supporting down the road. This will be composed at provisioning time. And as soon as the virtual machine boots up, Kubernetes will find all of the Kubernetes bits that are around. The SysEx can include systemd units to boot up kubelet, and those will be honored when the SysEx is merged. So you basically get your startup for free as well. You don't need to compose this at provisioning time, and that's some feedback we often get. Like, can you bake the SysEx right into the image? Of course you can. You can still download a stock image, stock distro image. You don't even need to boot it. You can loopback mount it. You can copy all the bits in there that you need. That is the SysEx, the symlink, and whatever else you need. And then you have your ready-made image. You still have the benefit of being able to update that image, given the right systemd sysupdate configuration, which you didn't have earlier when using Image Builder. So the update process is just systemd sysupdate polling an HTTPS endpoint, and as soon as a new version is released in that endpoint, you saw the SHA-256 sums file. This is basically the directory index for systemd sysupdate. It will download the new file. It'll copy it right next to the existing SysEx. It'll change the symlink. And from there on, it is up to you what to do. You can reboot the node, then it'll automatically refresh, or you can, apply some other logic in order to in-place update. So to sum this up, before we look at the update demo, we think switching to systemd SysEx in the very long term would significantly simplify the maintenance work of you folks, because you could use stock operating system images where the operating system, the distro provider would make sure that the latest bits are installed because they don't want insecure images in the clouds, right? So you would basically just reuse their work. You would decouple Kubernetes from the operating system. You could use this same Kubernetes SysEx layer for a number of vendors. And in fact, the SysEx that we're using for the Azure vendor is the very same bits, the very same SysEx that we're using for the OpenStack provider, and that we will be using down the road for other providers. You could even, do crazy things and ship your own containerd or whatever bits you need. And you absolutely must have control of. But you can separate concerns at basically the SysEx frontier barrier. You have cut down the version metrics to linear now, because the only thing you ever need to care about is Kubernetes. And you've won an update story. So all of the bits are there on the operating system layer. You just have to decide on how to orchestrate updates on the Kubernetes side. And that brings us to the in-place update demo.
Thank you. So, yes, so yeah, so this is something just to answer the question previously about the vanilla Flatcar thing. So this used to be the earlier setup, which included the Kubernetes version, but now the SysX would just contain the would just use the Flatcar version. So that dependency totally gets off. Now going off, so the machine came up. So if I see that, if I try to see the OS is 3602, the Flatcar, and the version is currently 1.27.6. So the reason I'm demoing this is because on the same version we have released a system. The bakery has a newer version, 1.27.10. So when we demo update on the cluster, it would jump, it would auto detect the version and jump to the 1.27.10 version. And let's see, and all the nodes are running. So let's go on to the terminal. Okay, so yes, screen sharing. Yes. Okay, so this is I'll open up a serial console. So this is something very similar to what Thilo demoed earlier. We could actually see the extensions in Etsy, which is currently.
Can you?
Oh, okay. I'll change the font.
Yes, please.
Yes.
This is a sign of me getting old. I can't see the tiny things anymore.
Is this better?
Awesome. That's great.
Great. Okay. So yeah. So as you see, the SysX log file is linked to the 1.27.6 version, and sudo -s system ctl status system this update. So we see that it's inactive now. But before this, what I'll do is that I'll install cured into the cluster so that we have a automatic reboot detection. So
actually,
that.
let's do it afterwards. So
okay,
there is
sure.
a very narrow window of time when sysupdate will update the SysX and create the file for QD. So
Sure.
if you want to show the file for QD, then
systemctl start system d this update. Okay, now this is done. Let's check the journal. System this update. Yeah, so as we can see, it what it did was it found the latest version, downloaded from the GitHub SysX bakery, and installed it in the proper location. So let's look into the Etsy extensions again, and we will see that it's now linking to the latest one. So now let's go ahead and install cured.
can you show? Can you do an ls/run? Because that's
sure.
how it's awesome. I love it. That's what I love with QD. This is how you communicate with QD. You just create a file.
Sure.
It's in /1. Yeah.
Yeah. So this has the reboot required file, which Cured usually looks for. So now let's go ahead and check for your is there a chat? Great. Okay, so let's go back to the terminal. I will need to share the thing again. terminal share. Okay. So let's apply it. Okay. Oh, sorry. Set measure. Hopefully it's running now. It's view system. Okay, it checks for 30 seconds. So okay. So yeah, so I guess it did the reboot. Let's check. Yeah. Let's wait for some 30 seconds. Let's do this.
Can we check with kubectl which Kubernetes version is reported for that node?
Right now, I would need to reshare my screen, but right now it's showing. It's still showing .6. It's after the restart that it restart the service and then reports the latest version. And
it didn't restart yet. Okay, that makes sense.
Yeah, waiting for the 30 seconds to get over. It's a long time.
This is the demo effect. Usually you would just, make QD as part of your deployment and have it handle the reboots automatically.
Right. Yeah, so there it is. Here's the reboot.
Yay.
Great. So let's go back to now there's a reboot happened. Let's go back to this terminal. And so the last time I checked, it was still the old version when Kilo asked. So let's check it now. And we have the updated version. So yeah, that's for the demo. Handing back to Tilo again.
I think Jack has a question.
Yeah,
Oh,
it's
yeah.
this looks really clean. Is this sort of traditional flow of paving updates and waiting for a reboot somewhat new to Flatcar? My prejudice for Flatcar has been that it's more geared towards immutable infra, and you wouldn't do this kind of thing.
It's actually the way you in-place update the operating system on Flatcar nodes as well. And even for that, we also support QD. The default which we disable for cluster API is even that as soon as an update is detected, it's downloaded and then the node reboots. And then you have like the latest operating system version, which may not be desirable for all workloads. So for cluster API, we switch it off. But it would, if you have a managed Flatcar node that would download and stage the new operating system version, but not reboot, it would also create such a file. And then QD again could take over and basically keep your cluster fresh. And we're using the same mechanism here to keep the Kubernetes version fresh on your cluster, right? Okay, I think 1 or 2 more slides. Here we go. Yeah, as I said, usually you would have an update strategy in place, or even have a default update strategy defined by cluster API, maybe like a little longer from now, that would automatically handle that and keep your cluster fresh and secure. That said, you've basically seen the state of our work right now. We believe it's production ready. We have a good concept from the operating side of things regarding updates. and regarding shipping Kubernetes versions. But I mean, you folks from the Kubernetes control plane, you may have your own ideas about how this should be signaled in worker clusters. Maybe report up to the control cluster. And that would take some integration either with QD or then there's this other controller that also exists. That's the Flatcar Linux update controller, our very own idea of how this should work. This also focuses mainly on operating system updates, but it could be extended to cover Kubernetes sysext updates as well, because sysext handling is so easy. It's simple and straightforward. And then is something, sysext is currently a very good thing for immutable Linux distros like Flatcar, because as soon as you merge a sysext, whatever hierarchy you merge it into becomes read-only. So in our case, because the Kubernetes bits were in /usr, the whole of /usr turns read-only. That is not a problem for Flatcar because /usr is already read-only. Like, it's not a surprise for us. If you do that on like a very recent Ubuntu, which you absolutely could, because systemd is shipped with the latest Ubuntu, I think the operating system would not take it as well. But we have work ongoing to change that. So yeah, we actually have a PR up with upstream systemd that will let you redirect writes that go into the mounted sysext back to the original base directory where it was meant. This is PR, where they were meant to land. And what you can build is basically a system where you apply a sysext on /usr, but you still have the original /usr writable. As I said, that is work in progress, but the PR has progressed pretty far, and we hope to get it merged for systemd 256. There's like lateral work ongoing that happens in the kubeadm bootstrap area. There was a request a long time ago to have like a more stricter separation between kubeadm and between bootstrap, and we believe that work that we're doing here is kind of has kind of a synergy for that, because it will make the separation way easier to implement. So we're working with those folks. They're aware of what we're doing, we're aware of what they're doing, and we think there's kind of an end-to-end dependency where we will meet at the end and come up with a very simple system that is also simple to implement. And lastly, something that we want to investigate, Flatcar is ignition-based, but integration with Cloud Init-based distros should be very easy, because you just instruct Cloud Init to download a bunch of files and create a bunch of soft links, and you're done. So that is also something that is on our roadmap. That's pretty much it. We are on Slack, we're on Metrics, we have office hours as well, where you can tune in and say hi. We will stay in contact with you folks. We're planning to demo this to the AWS and to the vSphere provider later this year. And then after getting your feedback and the feedback from the other providers, actually make a kind of a proposal to Core Cluster API to look into this as potential way to update Kubernetes and to abstract from operating systems. Jack.
Great, this is super, super cool. What, anybody have any ideas how we get this into CAPI so we can support in-place upgrades? Because I assume that in your demo environment, the kubeadm control plane resource disagrees with the nodes about what version they're on. We're sort of hacking that out of band, is that right?
Are you talking about the control cluster?
That's right. So the typical upgrade flow would recycle all of the machines and Azure machines to use a machine built from a new version. So doing this in-place upgrade would definitely require changes in CAPI so that CAPI would know about them.
Yes.
Does anyone have we come up with any ideas about how to do that integration? Because I think this is a need in CAPI, and I'd love to give a thumbs up to forming a feature group around that.
So that is kind of where our expertise ends, right? We're the
Cool.
operating, the plumbing level guys, and we're actually looking for help. So
Great.
no, we don't. But we do the presentations with you folks, with the providers, for exactly that reason. Like, you know what you're doing on the control plane, right?
Well, Matt, you're raising your hand. Maybe do you have any notions about how this could be done? And then I assume you had a different question.
I have more image builder related questions. I wasn't thinking about that part of it so much, but
Cool. So
I agree that it sounds like
I'll make a vote that you'll get our help. I think that this is great and should go to Cappy. I don't quite know how it would fit, but I think it would be a really powerful improvement.
Awesome.
I'll go ahead with your image builder questions, Matt.
Yeah. So, I mean, I guess I'm curious how, so image builder does a lot of other stuff right now, including like installing containerd itself and things like that. So presumably that could be fulfilled by also having a sysext for containerd, which you do have, but I assume it's for Flatcar specifically, but
our containerd sysext is actually operating system dependent, and we update it in lockstep with the operating system. So this is an interesting kind of question, right? And I would say it all depends where you folks want to draw the line. Like, should containerd be part of your stack? Should you own like most of the user space stuff that you need on the actual host system, or do you rely on containerd shipped with the distro and just make it an installation thing with cloud in it, right? In my own personal point of view, I would actually rather have it in my own sysext than from anywhere else, because that way I can entirely end-to-end test it, and I only rely on the kernel that my guest operating system runs. But you know, this is not like a strong opinion. You should do whatever works best for you and for managing releases, right?
Yeah, it's just, you know, if we're gonna use the sysext mechanism to install Kubernetes, it would be great if we could do that for all the other things we need to get a node that works in Cappy, which isn't just Kubernetes. Obviously, there's a lot of other pieces.
Yeah.
So it'd be yeah, because otherwise we just have a smaller version of the exponential growth problem where we're maintaining base. Maybe we could just have one base image in an ideal world with just one version of containerd. That we might get away with that, but we'd still have to maintain a base image. Whereas, you know, the holy grail would be that we don't even worry about a base image and we just pull latest Ubuntu, put a bunch of sysext extensions on it, and we're done. Would be great.
Correct. That's kind of the end vision here. Yeah.
Yeah. And then kind of related to that, image builder does a lot of little tweaks and things to kernel parameters, TCP, other config files that are very distro dependent. And so I guess the answer for how you accomplish that would be maybe you could write a little systemd unit and include it in. But some of these things are pretty, and maybe have a sysext, a generalized sysext that you could download. Then it does all these little tweaks with, I suppose, systemd units.
I mean, ideally, like in a perfect world, distros would be interested enough in supporting cluster API to ship that as an installable package, right?
Yeah.
And then you would just make sure, because distros are more expert in distro tuning than Kubernetes folks are, probably. And but in a less than ideal world, this could also be included in the sysext that would then either figure out like what distro I'm on and what to apply, or just apply a generic set of options and tunables that you ship.
Yeah. Yeah, I totally agree. And then a last thing is, do you think have you noticed any noticeable performance penalty, or do you think there would be one for doing this at the most flexible way seems to be doing this at provisioning and boot time.
Yeah.
But obviously it's probably a little more optimal to have it all baked into the image, but I'm just curious if this adds any noticeable.
So I mean, you have a minimal kind of delay, a few dozen milliseconds or so, maybe a second in the initial boot. But so the Kubernetes sysext, I think, is less than 100 megabytes. We host it on GitHub. We provision it at boot time, and you don't. It's negligible. Like the download time of that is negligible. So I wouldn't worry about that.
And then I guess for like an air gap thing, you'd probably have to you just bake that in.
You bake it
Squash FS
in,
or whatever.
you bake it
Yeah.
in, and I mean the air-gapped environment would need some kind of server to pull other updates from, right? And it's very, very straightforward to host an HTTPS server nowadays. So all it ever needs is an HTTP or HTTPS URL where systemd could go and fetch those updated images on. And then you of course have control over what versions go into your air-gapped environment. But I mean,
Right.
you could also bake it in and do AB upgrades. Like this is not gone. It's actually even easier with systemd SysX to bake those in than it is with Image Builder.
Yeah. Well, this is great. I really am pretty excited about this. What other questions do people have?
I haven't looked at the agenda. I hope it's light. This
It-
was definitely worthy of
This was
taking up
the
the
entire
entire.
agenda, basically. So
Okay, great.
glad we spent so long on it because it was worth it.
Well done.
All right. Well, if that's all we have, Cyan, Thilo, thank you very much. If you have anything else to say, otherwise we'll move on to the remaining topic, which is just I was asking, should we go ahead and should we defer a patch release to next week, or should we try to squeeze one out today, assuming that can merge?
What's
Sorry,
the
I'm
delta?
not sharing screen any longer. And that's a good question. I don't actually know the overall delta. I know we had a couple fixes in there, but I was basically saying, yeah, Willie, go ahead. Sorry, I'm talking.
Oh no, you're good. I think maybe it's a good idea to wait for 1.6.2 because that fixed like a regression upgrading from U1 Alpha 3 and Alpha 4. But I think that's like a CAPI specific thing, so that might not affect us, but it might be good to wait for it if it's not like urgent that we need to patch release.
Yeah, that was kind of my thinking as well. So are there any, I guess I should have done the diff, but all right, let me just do that now. Well, oh, hey. What is going on with my, well, anyway, I won't waste your time. I'm having some UI issue here, but why don't we take that as a tentative plan? We'll wait until this afternoon and hopefully that will have merged. And if not, should we do a patch release anyway, or should we just pull our thumbs till next week? Since we try not to do it on Friday.
Sounds.
Oh my, that
sensible to
freeze?
me. Nope.
Oh, my video froze. Okay, that's the plan. Is there anything else? I think I'm still live here, but all my video has frozen, which is always exciting when you're presenting.
We can still see you move.
Okay, good. Well, and I don't know if anyone's raised their hand because Zoom seems to have died, but I'll assume we're all good. Otherwise, just shout something out. And we will call it a wrap, and I'll see everybody next week, hopefully. And thanks so much for the demo. This was great.
Thanks for having us. Bye,
Thank
folks.
you.
Thank you.
Thanks, everybody.
I cannot stop sharing. Oh, there we go.